Welcome to Chemistry Solutions with Steve. This is a GCSE Chemistry paper from 2018. It's Higher Paper 2, and you can download this paper from the AQA website. This video can be used by teachers who perhaps are not specialist science teachers or not specialists in chemistry, and obviously by students. Students, you can do this paper on your laptops, one question at a time. Stop the video, go back, mark your work and get instant feedback. Or you can treat it as a mock exam and sit down, do the whole paper in one go, on paper. The choice is yours. Right, let's get cracking. Question 1.1. This question is about chemicals in fireworks. Coloured flames are produced because of the metal ions present in fireworks. What colour flame would sodium ions produce for 1 mark? This is a straight recall from the periodic table or the work on analysing positive ions. And the answer is yellow or orange for 1 mark. 1.2. Name a metal ion that would produce a green flame. Well, there are a couple you could have had here. The obvious one from the syllabus is copper Cu2+ for 1 mark. Some fireworks contain a mixture of metal ions. Why is it difficult to identify the metal ions from the colour of the flame? This is because the colours in the flames are masked. So, to get 1 mark, you should write, the flame colours are masked. Question 1.4. Flame emission spectroscopy is used to identify metal ions in a firework. Figure 1 shows the flame emission spectra of 5 individual metal ions. A flame emission spectrum for a mixture of 2 metal ions. Which 2 metal ions are in the mixture for 2 marks? So we need to compare the mixture of the 2 metal ions with the spectrum above. And we can see, if you look at the yellow spectral lines, there's common lines between sodium and the 2 metal ions. And then if you look at the green turquoise highlighted ones, there are common spectral lines between lithium. So we can assume that the mixture of 2 metal ions contains lithium plus iron and sodium plus iron. The compounds in fireworks also contain non-metal ions. A scientist tests solution of chemicals used in a firework. 1.5. Silver nitrate solution and dilute nitric acid are added to the solution. A cream precipitate forms. Which ion is shown to be present by the cream precipitate? This is the classic halide ion test where you get the results where chloride ion is white, the bromide is cream, and the iodide is pale yellow. So we're looking for a cream precipitate, so we write bromide or Br1-. 1.6. Describe a test to show the presence of sulfate ions in the solution. Give the result of the test if there are sulfate ions present in the solution. So what we need is a test and a result, and that's for 3 marks. So the test we're going to look at, again, it's a classic one that you should have learned. A few drops of hydrochloric acid with a few drops of barium chloride, and the result, a white precipitate. So to get 2 marks, you must say add a few drops of dilute hydrochloric acid followed by a few drops of barium chloride. And for the 3rd mark, you must state that you get a white precipitate as the result. Question 2. Methylated spirit is a useful product made from a mixture of substances. Table 1 there. Well, we'll look at table 1 in a minute. Question 2.1 is asking us what name is given to a useful product such as methylated spirit. And we should know this for 1 mark. It's a formulation. Formulation for 1 mark. 2.2. Calculate the percentage by mass of methanol in methylated spirit. So now we're going to have to go back up to table 1. This is a 2 mark question. Now, if we look at table 1, what we need to do is add up all the substances that are in methylated spirit. So we'll get our calculator out and we'll add those up. We can see that they come to 293.3. So now we find the mass of methanol, 23.3, and we've got to now find the percentage of methanol in the 293.3. So we're writing it out here on the answer grid. Mass of methanol, mass of methylated spirit. We're going to divide the 23.3 by 293.3, times that by 100%, round it up to two significant figures, and the answer 7.9%. 1 mark for the fraction times 100 and 1 mark for your 7.9. Next question. Methylated spirit contains ethanol and is available cheaply. Methylated spirit also contains pyridine, which is a very unpleasant smell, and methyl violet, which makes the mixture purple. Question 2.3. Suggest why pyridine and methyl violet are added to ethanol to make methylated spirit. This is a 1 mark question, and methylated spirit is an alcohol and it's cheap. So they put these things in to put people off drinking it. Question 2.4. Suggest one use of methylated spirit. You can probably answer this question without doing any chemistry whatsoever. The bog standard answers are the usual things like solvents and antiseptics, and any one of these will get you 1 mark. 2.5. Describe how ethanol is produced from sugar solution and give the name of this process. So this is for 3 marks. Well, the process is obviously called fermentation. Again, it's a bog standard recall. You probably did it in biology as well. Now, in fermentation, you add yeast and you keep the solution warm. You could also keep the solution in an absence of oxygen, which is what we call anaerobic conditions. But it's an either or, warm or anaerobic. Question 2.6. Figure 2 shows part of the displayed formula for ethanol. Complete figure 2 for 1 mark. Now, this is an example of drawing a structural formula. So when we look at ethanol, what do we know about ethanol? It has a functional group OH. So the first thing we're going to do is write the O and the H with our covalent bonds in between. Now, this carbon needs 4 bonds, and there can only be carbon hydrogens, because if we look at the formula for ethanol, C2H5OH, we need 2 carbons, which we've got in the middle there, and then we also need 5 hydrogens joined to those carbons and the 6th hydrogen outside the oxygen to complete that for 1 mark. 2.7. Name the gas produced when sodium is added to ethanol. Again, this is a simple recall from organic chemistry. If you're not sure about this, set up a revision card. And the answer is hydrogen for 1 mark. Question 2.8. Methanol is used to produce methanoic acid. What type of substance reacts with methanol to produce methanoic acid? Once again, this is a basic recall from your organic chemistry. So alcohols to carboxylic acids are oxidation reactions, so we will need an oxidizing agent, beg your pardon. Acceptable answers would also be a permanganate like potassium or dichromate also. Question 3. This question is about gases. Figure 3 shows how nitrogen is used in the Haber process to produce ammonia. You've got figure 3 here. You've got some nitrogen and gas X going into a reactor. You've got a condenser and you've got some ammonia coming out the other end. You've got some unreacting gases being recycled. So 3.1, gas X in figure 3 is obtained from methane. Name gas X. Well, this is an equation you should know in the Haber process. Haber, you say Haber, I'll say Haber. And it's the reaction of nitrogen with hydrogen gas. So to get 1 mark for this question, you must write hydrogen. 3.2. Give the approximate temperature and pressure used in the reactor. Well, again, this is basic recall of the Haber process. The temperature is 450 degrees Celsius, so anywhere between 400 and 500 gets you 1 mark. And the pressure is 200 atmospheres, and that's anywhere between 150 and 250. And you must have the units, degrees Celsius and atmospheres. 3.3. The mixture of gases from the reactor cools in the condenser. Suggest why ammonia condenses but the other gases do not. Well, this is about boiling point. Gases condense because of their boiling points, and ammonia has a higher boiling point than the other gases. The other gases have got lower boiling points, so the ammonia condenses first. So ammonia has a higher boiling point for 1 mark. Next question. The Earth's early atmosphere was different to Earth's atmosphere today. Scientists think that the Earth's early atmosphere was like the atmosphere found on Venus today. Table 2 shows the amount of carbon dioxide and oxygen in the atmosphere of Venus and Earth today. So here's table 2. We've got some percentages here of today on Venus and percentages on Earth today. So, question 3.4. This is a 6 marker. The percentages of carbon dioxide and oxygen have changed from the Earth's early atmosphere to the Earth's atmosphere today. Explain the processes that led to these changes. So if we look once again at the relevant section from the mark scheme, you can see level 3, you need relevant points, reasons, causes are identified, given in detail and logically linked to form a clear account. That's what you need to be able to write. So, as with all of our 6 mark questions, we must plan. And so we use our pencil down the side of our page and we make a plan. And if we look at the pencil marks that I've made here on the left-hand side, we can see that carbon dioxide has gone down on the Earth. And this is because of volcanic action. Volcanoes produce water, steam, gas. The gas condenses, it forms oceans, and then the carbon dioxide, it dissolves into those oceans. It forms carbonates, which form sediment, and then this carbon is locked up in sedimentary rocks. Now, if we look at the oxygen, that's gone up, and this is because of algae and plants first appearing. These absorb carbon dioxide through photosynthesis and release oxygen, and therefore the carbon is locked up in the fossil fuels as well. So we use those notes, and this is what we've got. This is our full answer. Big reduction in carbon dioxide. Lots of volcanoes emitted lots of water vapour which condensed into liquid water and formed the oceans. Carbon dioxide dissolved in the oceans and animals convert it to carbonates. The carbonates end up as sediments and form sedimentary rocks, locking in the CO2. The big increase on oxygen. Well, algae and plants appear and begin absorbing carbon dioxide, which helps the above, but also release oxygen through photosynthesis. 3.5. Why are scientists not certain about the percentage of each gas in the Earth's early atmosphere? For 1 mark. This question is a similar theme to what scientists think about what happened in the Earth's early life cycle. And basically, things that happened billions of years ago, there's very little limited evidence. So to get a mark, this occurred billions of years ago, and there's limited or no evidence. Question 4. A student investigated the colours in 3 different flowers, A, B and C. The colours are soluble in ethanol but are insoluble in water. This is the method used. And you can see the steps there, 5 steps. You can read those yourselves. You're crushing, adding ethanol, filter. Figure 4 shows the apparatus used. Oh, they look okay, apart from these two here. Start lining ink and water. They could be dodgy. Let's have a look at the question. 4.1. The student made 2 mistakes in setting up the apparatus. Let's have a look. Well, we've highlighted them here, haven't we? That's ink when it should be pencil. And that's water. That won't work. That should be ethanol. Okay? And we need to find a reason or a problem that it'll cause. So we can see here the pencil line, the ink will run, it'll dissolve. The water, the colours won't move because the solvent is ethanol, so that the ink will just sit on the paper. So to get 2 marks for the first bit, start line drawn in ink, ink will dissolve in solvent. So to complete the set for mistake 2, the solvent is water for 1 mark, and the problem caused, the colours will not dissolve and not move. And that's your 4th mark. Question 4.2. Another student set up the apparatus correctly. Figure 5 represents the student's results. Give 2 conclusions that you can make from figure 5. So let's have a look at what figure 5 is going to tell us. If we look at the individual flowers A, B and C, the spots or the colours that have come from those flowers are shown here. And for A and B, there's just 1 spot, 1 colour. So that means A and B contains 1 colour. If we look at C, in the purple here, you can see there are 2 spots. So in flower C, there must be 2 colours. Now if we go across the chromatogram, we look at lines. There are no 2 colours across the chromatogram that are in line. That means that the flowers have no common colours. So there are 4 possible answers. Pick any 2 from 4. 4.3. Colour A has an RF value of 0.65. Colour A moves 3.2 centimetres. Calculate the distance moved by the solvent for 2 marks. So this is an RF formula problem. RF is the retention factor, and the formula is RF equals the distance the substance travels divided by the distance that the solvent travels. So if we rearrange the formula, we'll find that the distance moved by the solvent is equal to the distance moved by the substance divided by the RF value. All we need to do then is sub in these numbers, crunch your calculator. You get a very long number which you will reduce down to 2 significant figures at 4.9 centimetres. Question 5. Sodium thiosulfate solution reacts with dilute hydrochloric acid. The solution becomes cloudy as the reaction takes place. Equation for the reaction is sodium thiosulfate plus hydrochloric acid goes to sodium chloride plus sulfur dioxide plus water plus sulfur. Explain why the solution becomes cloudy. And this is a 2-mark question. The key to the question is this part of the equation here, the sulfur. And if you look in the bracket, there is a S, which means solid. And that means that solid sulfur forms something called a precipitate. So in order to get 2 marks for this question, you must write down that solid sulfur is formed and that the cloudiness is due to something called a precipitate. Question 5.2. Plan an investigation to show how the concentration of the sodium thiosulfate solution affects the rate of the reaction with dilute hydrochloric acid. Your plan should give valid results. Whenever we see valid results, that means we must control some variable. We must also look at the mark scheme. If you look down below, this is what you need to do to get level 3. The method would lead to the production of a valid outcome, all key steps identified and logically sequenced. You've got to do that to get your 6 marks. Now remember, we use our pencil and we plan this down the left-hand side of the paper. So what we've got to look at is we've got to measure a volume of sodium thiosulfate. We put this into a conical flask. We measure a volume of hydrochloric acid. We put a black cross on a piece of paper, and this is going to enable us to time the reaction. At the same time, we add our hydrochloric acid to the flask, swirl it, start the stopwatch and put the flask on the black cross. Stop timing when you can no longer see the black cross through the conical flask. Repeat this twice more to get an average mean. Repeat for at least 4 more different concentrations of the thiosulfate. Your control variables in the reaction are going to be the concentration of the hydrochloric acid, the volume of the hydrochloric acid, and the total volume of the sodium thiosulfate. Now we've got a plan, we just work through this, writing it out sentence by sentence till we've got our 6 marks. Over the page to question 6. This question is about polymers. Question 6.1. Polyesters are produced when monomers join together and lose a small molecule. Name the small molecule lost. For 1 mark, you must write water. 6.2. Polypropene is produced from propene. Complete the structure of polypropene in the equation. These are the structural formulas for monomers and polymers. These are quite common. You'll have done these in your lessons on organic chemistry. So that double bond on the left becomes a single bond on the right. The 4 groups, CH3, H, H and H, they must all be written in as they were on the monomer. Okay, and then we write on the bottom right-hand corner, N for number. N is a very large number. So 1 mark for the single carbon-carbon, 1 mark for the 4 groups, 1 mark for N. 6.3. Carpets are made from polypropene wool, a mixture of polypropene and wool. Polypropene wears out more slowly than wool. A mixture of polypropene and wool makes carpets more sustainable than using just polypropene or just wool. Suggest why. You have to be clear exactly what this question is about. You're comparing the mixture of the polypropene and wool and then the 2 separate polypropenes and wool. So let's have a look. We've got down some notes here. So the polypropene is non-renewable. Okay, it needs a lot of energy to make it, and it's non-biodegradable. Okay, so there's some things to note. Wool. It wears out more quickly, so we'd have to replace it more often. And the thing about wool is it's made from sheep. And what do sheep need? A lot of land to graze on, which you could use to grow food. So as you can see, there are 5 actual answers here, but you only need 2 from 5. Next question. Polymer fibres are used to make firefighter uniforms. Table 3 shows some of the properties of 2 polymer fibres. So in the table we've got some polypropene and some polyester, and we've got these properties: density, melting point, flame resistance, water absorption. 6.4. Evaluate the suitability of polypropene and polyester for firefighting uniforms. And this is a 4-mark question. So here's the table. We're going to come back to that in a minute and have another look at that. Now, you can either decide to use one or the other. You can compare polypropene or polyester. Let's look at polyester. So polyester, well, we can see from the table, it's got good flame resistance. It's got a high melting point. It's got high water absorption. So these are all good things we can use to compare it to polypropene. So let's look at some of the negative things for polyester, some of the disadvantages. Well, the polyester's got a high density, which makes the cloth heavy. It absorbs water when it gets wet, which could also make it heavy. Now, it's an evaluate one, so you have to make a choice. So we'd put something like polyester does what it needs to do in terms of flame protection and melting. If you look at the actual answer, we've got quite a few different bullet points here, and in the mark scheme you only need 4 of those. So we've talked about advantages of the polyester, disadvantage, and then in the end we've made a choice. This is the choice here. Question 7. Older cars are tested each year to measure the amount of pollutants contained in exhaust flumes. Table 4 shows the maximum allowed percentages of exhaust pollutants for petrol cars, and you see table 4 there with all the details in. 7.1. Explain how carbon monoxide is produced when petrol is burned in car engines. Well, this is about incomplete combustion, and what that means is the fuels don't have enough oxygen to produce carbon dioxide, so they make carbon monoxide instead. So, for 2 marks, you must say carbon monoxide is produced by incomplete combustion because there is a lack of oxygen. Question 7.2. Suggest 2 reasons why the maximum allowed percentage of carbon monoxide has decreased for newer cars. If we go up to the table, you can see what we mean here. You can see older cars were allowed a higher percentage of carbon monoxide. So there are 4 possible answers here. The first thing you need to say is that carbon monoxide is toxic. That's something that we all know. There are more cars on the road in recent years, so there must be more carbon monoxide. There is also a greater public awareness of issues like pollution, and there is improved engine technology. So any 2 of those for 2 marks. Question 7.3. Give 1 reason for having a maximum allowed percentage of unburnt hydrocarbons in exhaust fumes, and this is for 1 mark. Well, the obvious answer is that you need to reduce breathing problems like asthma and lung cancer because the unburnt hydrocarbons add to that problem. You could also say to reduce global dimming as well. Question 7.4. Describe how oxides of nitrogen are produced when petrol is burnt in car engines. And this is a 2 mark question. Now, this is about nitrogen and oxygen from the air combining together to form oxides of nitrogen, NOx we sometimes call them. So we know the oxygen comes from the air, and we know that oxygen reacts with most things. Now, nitrogen also comes from the air. Normally nitrogen wouldn't react with oxygen, but in the piston of the engine the temperature is so high that the nitrogen combines with the oxygen. So in order to get 2 marks, 1 mark for saying nitrogen from the air reacts with oxygen, and the 2nd mark for saying at a very high temperature. Question 7.5. Nitrogen dioxide is an oxide of nitrogen. Nitrogen dioxide reacts to produce nitrogen and oxygen in catalytic converters. Complete the equation for this reaction. The equation should be balanced. Now, this is a common generic skill you must learn in chemistry, balancing equations. So let's look at what each bit means. The nitrogen dioxide, that's our NO2. Nitrogen and oxygen both exist as molecules with 2 atoms. Okay, so nitrogen must be written in that space there as N2, and it is also a gas. So there's a mark for putting your nitrogen in that space there. So let's get on balance. Because there are 2 nitrogen atoms here, there's only 1 here. So if we write out the individual atoms, we can work out what we need to do. So we need to double the number of nitrogens, but that 2 must go in front, and we double everything. So that now means we've got 4 oxygens. We've only got 2 oxygens over here, so we must double that. So we put a 2 in front of there, and that balances for 2 marks. 7.6. Give 2 effects of atmospheric pollution which are reduced by using catalytic converters. Now, there are a number of answers to this. You could have acid rain, breathing or respiratory difficulties, the production of carbon monoxide, which we know is toxic, and global dimming. Any two of those will get you 2 marks. Question 7.7. The catalyst in catalytic converters is a mixture of 3 elements. Where in the periodic table are these elements most likely to be found? Tick 1 box for 1 mark. This question is about the periodic table, and transition metals are well known for acting as catalysts. So to get 1 mark, you must tick the box that says transition metals. Question 8. A student investigated how temperature affects the rate of reaction between magnesium carbonate and dilute hydrochloric acid. Method: heat hydrochloric acid 30 degrees, add magnesium carbonate, flask, measure loss in mass every 20 seconds, repeat 1 to 3, at 50. Explain why the contents of the flask lose mass. This is for 2 marks. Let's look at the equation for the reaction. We can see in the equation here, look, that we've got some carbon dioxide being produced. Carbon dioxide is a gas. So that's your first mark. And obviously the carbon dioxide has to go somewhere. So it's a gas, it bubbles, it escapes. So the flask will reduce in mass. Question 8.2. Table 5 shows the students' results for hydrochloric acid at 30 degrees Celsius. So you've got, it's a typical set of results. You've got a column for the time in seconds and then the loss of mass in grams. Plot the data from table 5 onto figure 6 and draw a line of best fit. And this is a 3-mark question. So let's have a look. You've done many of these graphs before. Use your ruler to draw your points on by making sure you've got them on the right part of each axis. As I say, you've done this many times before. Tick the plots off when you've done them. When you're drawing a line of best fit, try and turn the paper to an angle that suits you and use your elbow as a pivot and a nice smooth line. Now in this question, all the points correct, you get 2 marks, and for your line of best fit, it's 1 mark. Over the page for the next question. Figure 7 shows the students' results for hydrochloric acid at 50 degrees Celsius. Determine the rate of reaction, for 8.3 this is, at 50 degrees when the loss in mass is 0.95 grams. Show you're working on figure 7 and give your answer to 2 significant figures. Now there are 4 marks available for this question. Now you might recall this is one of those questions where you need to be able to calculate the rate of reaction by drawing a tangent at the points asked in the question. So in the question it's asking us for 50 degrees, 0.95 grams. So we get our ruler and we put our ruler across from 0.95 grams onto the curve, and then we try and draw a line of a tangent as close as we can to that point. Once we've got the tangent, we can now work out the gradient of that line. So we measure the value on the y-axis by looking at the points on the y scale and taking one from the other, which is 1.08 minus 0.70, and that comes at 0.38. And on the x value, luckily our line is on the 0 for x, so that comes out at 125. So we know our rate is going to be the value of y divided by the value of x. So we'll write this out on the space provided for our answers. The rate is y divided by x, which equals 0.38 divided by 125. That comes out at 0.0034. And if we do that then to 2 significant figures, that works out at 0.0030 grams per second. So we're going to get a mark each for the correct x and y values. Next mark, third mark, is going to be for that division sum, 0.38 divided by 125. And the final mark is the rounded up to two significant figures. This question is about methanol. 9.1. Methanol is broken down in the body during digestion. What type of substance acts as a catalyst in this process? Now, if you look here, you've got to tick one box for 1 mark. There are 4 on offer. We should know from our biology and chemistry combined that in biology, enzymes act as a catalyst. So put a tick in the enzyme box for 1 mark. In industry, methanol is produced by reacting carbon monoxide with hydrogen. The equation for the reaction is CO gas plus 2H2 gas in equilibrium with CH3OH. So that's carbon monoxide plus hydrogen goes to methanol. So, question 9.2. How many moles of carbon monoxide react completely with 4.0 times 10 to the 3 moles of hydrogen? So you've got 4 choices here, and we need to look at the equation. Now, if we look at this equation here, we can see that there's no number in front of there, so that means there's 1 mole of carbon monoxide. That 2 in front of the H2 means there's 2 moles. Okay, so there's a ratio here of 1 mole to 2 moles. Now, in the question, it's asking us how many moles of carbon monoxide react with 4 moles. So if we have 4 moles of hydrogen, by definition, we must have 2 moles of carbon monoxide. Turn over the page. 9.3. The reaction is carried out at a temperature of 250 degrees Celsius and a pressure of 100 atmospheres. The forward reaction is exothermic. Explain what happens to the yield of methanol if a temperature higher than 250 degrees is used. This is a 2-mark question. So this is testing our knowledge of equilibrium. If we increase a temperature at equilibrium, this favours the endothermic direction, which is to the left in the favour of the reactants. So, therefore, the yield will be smaller. In order to get 2 marks for this question, you must write in the space provided there would be a smaller yield for 1 mark because increase in temperature favours the endothermic direction for the 2nd mark. Question 9.4. A pressure of 100 atmospheres is used instead of atmospheric pressure. The higher pressure gives a greater yield of methanol and an increased rate of reaction. Explain why for 4 marks. So this is the equation from back in the question here, look, and we can see that we've got on the left-hand side 1 mole of carbon monoxide and 2 moles of hydrogen, giving us 3 moles in total. On the right-hand side, we've only got 1 mole. Now, we know from our previous lessons that if you increase the pressure in a reaction, the equilibrium shifts to the side of the equation with the fewer moles, which clearly is the right-hand side. So, to get 2 marks, higher pressure gives a greater yield because the equilibrium shifts in the direction with fewer molecules, i.e. forwards to products. In part, we need to explain why the increase in high pressure gives an increased rate of reaction. And this is all about successful collisions. The rate of a reaction increases if there are more collisions in a set time, and the increase in pressure brings the molecules closer together, so there are more collisions, so we get a greater rate of reaction. So to get another 2 marks, we must say increase in pressure will increase the frequency of collisions because the molecules will be closer together. Page to the next question. We're nearly at the end now. A catalyst is used in the reaction to produce methanol from carbon monoxide and hydrogen. Question 9.5. Explain how a catalyst increases the rate of reaction. This is about pathways. Catalysts can provide alternative pathways which will have a lower activation energy. So for 2 marks, you must write in the space provided, catalysts provide alternative pathways which have a lower activation energy. 1 mark for alternative pathway and another mark for lower activation energy. 9.6. Suggest why a catalyst is used in this industrial process. Do not give answers in terms of increasing the rate of reaction for 1 mark. And this is all about energy. The use of a catalyst means that the reaction requires less energy. 1 mark. Question 9.7. Suggest the effect of using the catalyst on the equilibrium yield of methanol for 1 mark. And if you recall from your chemistry lessons on equilibrium, a catalyst has no effect whatsoever on the equilibrium. Question 10. Disposable cups are made from a coated paper or polystyrene. Table 6 shows information on the life cycle assessment LCAs of disposable cups. And you've got your table there. We'll come back to that table in a minute. Now let's have a look at what this is all about. There's some information here about the raw materials, the mass of a cup, energy, etc., biodegradable, recyclable. So let's look at question 10.1. Evaluate the use of coated cup paper compared with polystyrene to make disposable cups. Use table 6 and your knowledge of understanding of LCAs. As with all our 6 markers, we must make a plan with our pencil down the left hand side of the paper. So, the raw materials first of all. Well, the raw materials of a polystyrene cup are crude oil, and we know crude oil is a finite resource. For a paper cup, then that's wood. That's its raw material, and it is renewable, but one of the negatives is deforestation. Manufacturing. They both require energy for manufacturing. Paper uses more energy and produces more CO2. Paper uses a lot of water, and it's heavier, so the transport is going to cost more. Okay, and you're looking at some of the figures here on the table, which we'll refer to later on. So if we look at usage, okay, both are single use, so there's nothing else to discuss there. Okay, disposal. Paper can release more energy for making electricity if you burn it. Polystyrene, however, when you burn it, produces toxins. Both show visual pollution. Paper is biodegradable, so that's an advantage. So we're going to put all this together in a nice long answer for our 6 marks. So if we look at the mark scheme, we remember that these 6 markers are marked holistically. And what that means is you don't get 6 marks for 6 points. It's an overall impression. So for level 3, you must make a judgment strongly linked and logically supported by a sufficient range of correct reasons. So in my long answer here, we've got a mixture of my knowledge, your knowledge and understanding, plus information from the table. Based on the provided LCA information, polystyrene cups have a lower energy requirement for production, lower energy release when burned, and are recyclable. However, coated paper cups are biodegradable, which is an advantage over polystyrene in terms of environmental impact. Coated paper cups use wood as raw material, while polystyrene cups use crude oil. However, the use of wood implies deforestation. The mass of one coated paper cup is 8.3 grams, whereas for polystyrene it is 1.9 grams. Therefore, transport costs could be higher. The energy required to produce one coated paper cup is 550 kilojoules, which is higher than the 200 kilojoules needed for one polystyrene cup. When burnt, a coated paper cup releases 166 kilojoules of energy, while a polystyrene cup releases 76. Now, here's the important bit. This is our evaluation, so we have to choose. So, paper cups would be able to produce more power if used in electricity generation. If polystyrene burns, it can produce toxins. Coated paper cups are biodegradable, but polystyrene cups are not. However, polystyrene cups are recyclable, but coated paper cups are not. I would choose, and you write your evaluation based on the evidence. Question 10.2. Calculate the energy needed to produce 1 kilogram of coated paper cups. Use table 6 and give your answer in standard form. Now, standard form, remember, this is when you do your times 10 to the power of, and this is a 2-mark question. So let's have a look at table 6. The mass of 1 cup in grams is 8.3, so we can work out how many cups there are in a kilogram. The energy to produce 1 cup in kilojoules is 550. So let's jot that information down. So what have we got? We've got 1 cup as a mass of 8.3 grams, and we can work out how many cups in a kilogram by dividing 1,000 by 8.3. That will tell us how many cups in a kilogram. And we multiply that by the energy for 1 cup. So here we are. Here's the sum. 1,000 divided by 8.3 times 550. So we crunch that on our calculator, and that comes out at 66,265.06024. Now, clearly, the question says give your answer in standard form. So, in standard form, that would be 6.63 times 10 to the power of 4 for 2 marks. And here we are at the last question, 10.3. Melamine is a polymer used to make non-disposable cups. Melamine does not melt when it is heated. Explain why. And this is a 2-mark question. Now, whenever we see anything about polymers not melting when they're heated, one word springs to mind, and that is thermosetting. So we know that melamine must be a thermosetting polymer. Now, what does that mean? And we need to explain this, why it's thermosetting. So if we look at the polymer chains here, a little diagram, between the polymer chains are covalent bonds, and we call these cross-links or cross-linked bonds. Please do not refer to them as weak intermolecular forces. They are strong bonds. So to get 2 marks, melamine is a thermosetting polymer for 1 mark. This means, that's the key bit, it has cross links between the polymer chains for the 2nd mark. Well done, and congratulations for getting this far.